Congruent and Similar Triangles, our newest geometry lesson in the unit. I'm going to do something a little different today, and that's immediately I'm going to drop down a blank screen, little whiteboard here, and do a little review on what it means to have congruent and similar triangles. So if I draw a triangle here, there you go, and I copy that triangle over, say, here. These are examples of congruent triangles. They are the exact same size, they are the exact same shape, they're the exact same color. If I was to draw the angles in them, they would be the exact same angle. Now if I take the same triangle though, and even though it has the same exact angles, what if I make it, let's see, what if I make it way larger? 3, 2, 1, boom. That is technically the same exact triangle, the same exact dimensions, but now you can see this gigantic one. These are not congruent, but similar, and you would also know that, like say I labeled these angles. Yeah, ignore it. Let's just go more of 66, 66. Let's see, that'd be 132. So I'd put this top one as 48. Okay. Alright, it's not perfect. These are definitely not to scale. But if your angles perfectly match, then you know that the large and small triangle are similar. However, if even one angle is off by even just a little bit, like say these bottom two were on the small triangle, like 67 and 65, then these would not be similar. If even one angle was off by even 1 degree, all the triangles are not similar. Okay. That will help us get started, and then I'll say more about that when we get going. So let's do it. Dive in, attempt quiz now. We have not been given any information on the sides, although it is obvious that the red triangle is much larger than the blue triangle. The question asks, are the triangles similar? So let's just simply compare the angles. 90, and this kind of looks like a 90-degree angle, compares with 90, but 33 is, even though it's close, it's a little less than 34. So no. These are not similar. If they're off by even just a little bit, they're not similar. All right, number 2 is going to bring in a second concept on why triangles can be similar. So let's go ahead and do the one we know from our mini lesson here. We got 53 and 32, so let's find the 53 and 32. That's definitely 54 and 32. 53 and 32, okay. But then we have, and let me zoom out here a little bit further. There we go. All right. We have now 2 triangles to compare their sides. I've got 16, 24, and 30. Down here I've got 8, 12, and 16. And I've also got 32, 48, and 60. So another way that 2 triangles can be similar, in addition to the angles being the same, is if their sides are proportional to each other. Meaning, if I multiply each of these sides by the same number, say 2, if I multiply each of these by 2, this would be 48, 32, and 60. So if I had a triangle with 32, 48, and 60, these would be similar because I would take the same number, in this case 2, and multiply it by all 3 sides so that proportionally this larger triangle was exactly double the smaller triangle. Now this is a little bit messed up because of how close it is. But let's check the smaller one. So we'll notice between 8 and 16, this is dividing by 2. 16 divided by 2 is 8, check. 24 divided by 2 is 12, check. 30 divided by 2 is 15. Oh my gosh. So this smaller triangle is almost similar. In the same way on number 1, those triangles were almost similar, but the angles were just barely off. If the sides are even just barely off as well, they're not similar. So in yours, figure out which triangle have the sides exactly similar and go with that as well as the angle answer. All right, number 3. In the similar triangles below, so they're just giving us automatically that the triangles are similar, angle S, that's what this little symbol here means. Angle S corresponds to blank. So we've got SRC and we've got our WNP. So first of all, notice that angle in, this 90-degree angle, matches R, this other 90-degree angle. And because this is 51, and we know from our earlier assignment that the angles inside a triangle add up to 180, this is going to be 180 minus 51 minus 90, which is 39. And similarly, this would be 51. So even though they're trying to trick you and they're facing the wrong direction, this 39 matches this 39. And this 51 matches this 51. So angle R matches angle in, angle W matches angle S, and angle P matches angle C. So S matches W, the two 39s. So I can select W. Match them up. Outstanding. All right. Notice we only have 8 problems today. Moving on to number 4. In the similar triangles below, angle S corresponds to blank. All right, let's look at S. S is in this triangle. It is the obtuse angle up top with no double or single tick mark. So down here, I'm just going to look for the obtuse angle with no double or single tick mark. That's in. In your face, we got the right angle on that triangle, even though it's not a right angle. Get it? Okay, great. So number 5, JD, which is maybe your name out there if you're following along, has a line segment. That's what this means here. Line segment JD. So J and D down here corresponds to blank. So J is the single ticked angle, and it's going to the angle that's smaller with no tick mark. So then the single tick angle is C, going to the one with no tick marks, M. So JD matches CM. And it must be in that order. We couldn't put MC. MC Hammer. Oh, that's kind of fun. So check this out. This is a total coincidence I just thought of. So JD matches CM, but if you go backwards and get your music on and have your DJ, well, who leads the DJ party but the MC? Huh. Oh, and it says you rock, like it's a rock concert. What? Mind blown. Wow. In the similar triangles below, JF, so J is going to be our obtuse angle going to the double tick marked F. So we need to go T to double tick mark E. If we go backwards there, ET, extraterrestrial, would match FJ. I don't know. Maybe you can come up with something clever for that one. Flying Jupiter. I don't know. All right, 7 and 8. This is where we're going to use our Desmos Calculator over here. That's why I got it open. If you don't have it open, get it open. I need to use the fact that these triangles are similar, and I know they're similar because these sides are equal in both, and this angle is also equal, which is enough to prove similarity. I need to figure out what my missing x measure is here. So for that, I got to figure out how many times larger my large triangle is than my small triangle. Here's how I do it. I take the numbers that match each other. In this case, my bottoms are 72 and 40. So I do larger one divided by smaller one. 72 divided by 40, since it matches. And that tells me that this larger triangle is 1.8 times as large as my small triangle. So then both of these numbers are 35. And to get both of these numbers, including x, I need to multiply, because it's getting larger, this 35 by my triangle constant of 1.8. So 1.8 times 35. If you have a problem where it's backwards, and x is not in the larger one, it's in the smaller one, I know some of you might, we're going to, instead of multiply, you're going to divide. You're going to take whatever number is here and divide by your constant triangle multiplier. When you do that, you should not get a decimal. You should get a whole number. And hopefully you get it right. We do the same thing on number 8. So I need to take my two sides that are the same. In this case, it's my top left sides here, 36 and 18. I can see off the top of my head that 36 is exactly double 18, but here you go. It's going to be multiplied by 2. And so again, I've got two examples that are basically the same where I'm going to take this smaller number and multiply it by 2. But if you are looking at a problem, and you easily could be, that's backwards, where like 16's up here and x is down here, divide. But for me, I do 16 times 2. I wish I had one of each, but that's just not what I got. Maybe I can hit redo and see if I get a smaller one. Give me a smaller one now. Random problems. Yay! Okay, perfect. So this is an example. Wait, no. Dang it. Even though it's backwards, I'm still looking for the large one. Okay, I'd still do 48 divided by 32. Drat. 1.5 times 16. 24. All right, maybe I'll just do one more. Give me a small one where you solve for x. Do it, do it, do it, do it. Yay! Okay, this is the smaller one, and it is the bottom one. Okay, so now I still match up my larger numbers on each other, 48 by 40. But now, because x is the smaller one, I do 24 divided by 1.2 instead of multiplying by it. And I get 20. Whew! Good thing I didn't have to redo that like 9 times. Or imagine if it was double digit. We could have been here forever. When you get it right, even if it's the third time like me, you hit submit all. You finish. You get that beautiful 100%. And you bask in the glory of your success this morning on this math assignment. As always, I hope this assignment finds you safe, happy, healthy, and well. This has been a virtual lesson from your math teacher, Dylan. Class, away from class. Have an absolutely wonderful day.